Hello, welcome to F-Grade Electronics, where we try to repair broken electronic devices. Today we have a motherboard, an AM4 motherboard, TUF Gaming X570-Plus. It came to me as broken, and I don't know what this is. Taped here. This looks like a plastic piece. Maybe it was broken off somewhere. I don't know. Let's put this aside for now. I don't know what's wrong with it. That's why I'm going to check the resistances first, whether we have a short or not. The meter is in diode mode now, and I'm going to probe ground from the display connectors. Yeah, this should be ground. Let's see. Yeah. $12, 5 and 3.3 volts are looking fine. This should be 5-volt standby, and this should be PS on. Yeah, we have nothing. This is ground, this is ground, this is 5-volt standby. No, this is PS on. Yeah, this is 5-volt standby. Yeah, okay, let's check the 12 volts for the CPU. This side is the 12 volt input, the upper side, and the lower side should be ground. Yeah, this isn't ground. Yeah, this one isn't ground, but I don't know why. Maybe it's a sans pen. Okay, the main inputs are looking fine. This should be the RAM voltage, and yeah, I thought these were through hole inductors, but we can check the CPU voltage rail from here. Yeah, it looks also fine. Do we have anything from the 12 to directly to the CPU? No. Okay, we can say that the MOSFETs are not shorted. This is probably the RAM supply, and it's a through hole inductor. Let's test the RAM supply. Okay, it's not shorted as well. There's an inductor here. This is probably for the PCH. Let's also check that. This one looks fine. But there is a 1.05 volts and 2.5 volts supply for the PCH. This is probably one of them. I can't see the other one. It's probably under the cooler here. Do I remove the cooler to check it now, or do I do it later? Let's do it later. Before doing that, I also want to check the MOSFETs right here. I see one here, two here, and some capacitors. This is probably a supply for the CPU. I can't recall the name, but it's for the logic of the CPU. The voltage depends on the generation of the CPU in the socket. And also there's an inductor there. I just noticed. I'm not sure whether it's for the PCH or the CPU, but it's not shorted. That's the important part for now. Let's also check this inductor. Yeah, it's looking fine. Okay, I know I'm going to connect it to a PSU and a CPU in the socket. Let's see. I have a Ryzen 5 2600 right here. It's a non-working CPU. I checked before starting the video that the second gen Ryzen is supported on this board. Some X570 boards don't support Ryzen 2000 series, but this board does support only the Ryzen 2000 series, not the 1000 series. Okay, one 8-pin is enough for now. Okay, let's turn the PSU on. It's on. Let's check the voltage on the power switch. The battery is charged. 3.12. This is normal. Do we have here 3.35 and 3.35? Yeah, let me show you. The upper one is the power switch. Yeah, this is normal, and this is the reset switch, and we have voltage here. So let's try to turn the board on. But do we have anything getting hot? Because of the 5-volt standby. The 5-volt standby is still 5 volts, so I don't think there's something shorted on the 5-volt standby rail. So let's try to turn the board on. It doesn't react. Let's plug in a CPU cooler with a fan to visualize it. No reaction. Okay. I'm going to try something, but I don't recommend doing it. I'm doing it because we have voltage here on the power switch, but we have no reaction to it. If I had a reaction like fans turning, like making 1 or 2 rotations then stopping, I wouldn't do this. I'm going to get a tweezer and short the PS on and see whether we have a reaction. The buzzer. Yes, and we heard the beep code for the DRAM, and the DRAM LED is lit up, and the motherboard still working. Okay. Let's turn the power supply off. Let's put some RAM in them. Okay, the PSU is on again. Still no reaction to the power button. Let's short the pins again. The PS on to ground. Oh, it's cycling. The LEDs are cycling. We heard a beep and what is this booting? Yeah, no VJ beeps coming. What? I'm going to plug a USB keyboard in and let's get a graphics card. Okay, we have a graphics card in the PCI Express socket. I plugged it to the monitor, and I also plugged a USB keyboard in the USB socket. We have RAM. Okay, let's try to turn it on then by shorting the PS on. Okay, we have no lights. Let's turn it off. I should have done this before, but I'm going to reset the BIOS by removing the CMOS battery. And we should have a clear CMOS pin down on the motherboard right here. I'm shorting these 2 pins. Okay, let's try again. Do we have a reaction to the power button? No, we don't. Let's try shorting the PS on again. Yeah, we have a reaction. The LEDs are cycling. We heard a beep. Is it booting? Yeah, I have a picture on the screen. Look, Let's press F1. Yeah, and we are in the BIOS. What? I'll try to turn it off from the power switch. Let's see. Yeah, it reacts to it. Okay. I think it didn't work when we tried to short the pins directly, but it works after we try to press the power button and then short the PS1. Let's try it again. PSU is off. Let's drain the capacitors. Okay. I'm going to try to turn it on. Like this. Yeah, we have no reaction. But I'm going to press the power button. Well, it's on. And yeah, we have a reaction. Okay. So the board is reacting to the power button, but it doesn't turn on. Yeah. And it's on. Okay, let's disassemble the board, and I'm going to look at the Super IO to see whether we have something shorted or we have a knocked off component like a register transistor. Okay, let's power it off and disassemble the board. There's nothing on the board except the CPU, and this here is the Super IO chip, this Novoton chip. By looking at it, I don't see any burn marks or anything. Let's check this MOSFET. Yeah, nothing is shorted here. We have some chips missing here. But I think this board is like this from the factory. Look at here, this part looks different. Let me clean it with some isopropyl alcohol. I'm going to clean the whole area. Yeah, this doesn't look factory. Yeah, we have a little blob on each pad, but these two pads don't have a solder blob. Let's try to find a board view for this board and check whether there should be something there or not. Here we have the board view for this motherboard, and this is the Super IO chip, and this is the component that I thought was missing, and I was right. This is a 0 ohm resistor. There should be a 0 ohm resistor on the board. And these two are no assembled. This means these are not there from the factory, but there should be a 0 ohm resistor right here. But while looking at what this resistor does on the board, and after seeing this image, I thought I've seen this exact image before. It was a deja vu, and I couldn't figure out where I've seen this exact image before. So I started searching, and when I searched TUF X570 repair on YouTube, I saw this video from Mainboard Medic, and I know I watched this video before. Let's check it out together.
Hello and welcome to yet another video. Today,
Yeah, this looks like the exact same motherboard as ours, but this is the Wi-Fi model. Mine is not. And when I saw this, I knew I have seen this image before.
like that it was ever like connected or not. Like
Yeah,
the
check here.
found one thing, which is this. Look at this. I thought this might be knocked off, but this is not assembled, as you can see. But this resistor right here is supposed to be a 0 ohm resistor responsible for deep S5, so a sleep state. And this might be the cause for our problem. The pad really doesn't look like that it was ever like connected
And
or not.
yeah, let me show you what he does. Yeah.
So, out of curiosity, I went to the point in the board view where I saw that it's supposed to have a connection where the zero ohm resistor is supposed to be, because I couldn't find any damage on the backside. And look, let's have a look at this. Look at the power consumption now. We are at 80 milliamps that we've seen before. And look what happens when I connect with my tweezers to these 2 points that I've been talking about. If I connect these 2 points, you see the RGB turns on and our power consumption goes high. And if I press the power button, we even have reaction to the power button as soon as I short these two.
Our board has the exact same problem with this board. This board on Mainboard Medic's YouTube channel. You should definitely check his channel out if you're into ATX motherboard repairs. He is very good, like really good at what he's doing, and even if I know about motherboard repairs, I still learn a lot from his channel. Definitely check him out. If we come back to the board view, this was the resistor that was missing, and it's connected to the Super IO chip right here. This is the O deep S5 pin. This is about sleep states, and this part is O deep S5 R1. This becomes S5 after this resistor. This R1 means that it goes through a resistor to become O deep S5, and this is the resistor. And if we check where it goes to this resistor right here, this 2.7k resistor, and it is connected to another 2.7k resistor, and it's connected to this P-channel MOSFET. If we look at the other two pins, we see 3 VSB ATX and 3 VSB. This first pin is the gate pin, and this is the drain of this MOSFET, and this is the source. When since this is a P-channel MOSFET, when pin 1 is high, it doesn't connect pin 3 to pin 2. But when this is low, pin 3 goes to pin 2 and 3 VSB is created. And we know that 3 VSB is an essential signal for anything to turn on, from CPU to PCI Express devices. Everything needs 3 VSB to turn on. When it is not generated, nothing on the board can turn on. And Super I/O is responsible for this to go low, and 3 VSB is created when the Super I/O pulls the voltage on this pin low. Yeah, this resistor is essential for this purpose. Okay, so when we try to turn the PSU on by shorting the PS on to ground, the board started working. Why? This position, this gate is not low even if we press the power button, because it's not connected to the Super I/O chip. So how does it turn on? Is 3 VSB generated elsewhere? I looked at it and couldn't find anywhere else that 3 VSB is generated. So I checked this pin again. Is something else pulling it low when we try to turn the PSU by forcing it? And I saw this tiny resistor, this 1k resistor right here, and it goes to O deep S5 12 volts, and this is connected to this N-channel MOSFET. The gate of this N-channel MOSFET is connected to ground. The source is connected to 12 volts, and the drain is connected to this resistor right here. Okay. So when we force the PSU to turn on, this minus 12 volt is generated from the PSU. So what it does is, if you look at it like this is ground, 0 volts, this is minus 12. How is it controlled? Normally we see N-channel MOSFETs controlled from the gate by a controller or something else, but this time it's ground. How is it controlled? When this is minus 12, think of it like 0 and this as plus 12. So this becomes plus 12 and this is 0. So this is connected to pin 3 when there is minus 12 volts on this pin. And there's minus 12 volts and this starts conducting. This gate of this P-channel MOSFET right here is pulled low through this resistor and the board turns on and stays on because we have minus 12 volts. But when we don't have minus 12 volts, Super IO is responsible for this gate to be pulled low. But since the connection here is broken, it can't pull it low. But when we force it, minus 12 volts pulls this P-channel MOSFET, this gate of this P-channel MOSFET low, and the board stays on. That's the explanation. It took me a while to understand why it stays on when I try to force the power supply on. And this is the explanation. So let's try what mainboard medic was doing on the board, on our board, to see whether it's going to work or not. Now we are back on the board. Let's see, let's get a pair of tweezers and let's turn the power supply on. Okay, I'm going to do exactly what he was doing in the video. I'm going to short these two pins to see what happens. Yeah, the LEDs are on now. Exactly the same thing. And let's try to turn the board on. Yeah, the board turns on and I don't have to do the shorting anymore because the minus 12 volt has taken over the control of O-Deep S5. But to be able to control it through the Super IO chip, we need this resistor. So let's solder a 0 ohm resistor there. We need to solder a new 0 ohm resistor right here between these two pads. I want to prep the pads first by applying some solder. Yeah. And I'm going to grab a 0 ohm resistor. Like this. And now let's apply some hot air. Yeah. It's flown in its place nicely. Let's clean the area while it's still hot. Yeah, looks clean. And now let's try the board again. We have the board assembled with a CPU and CPU cooler with dual channel RAM, and also let me get a graphics card. I need to lift the board a little bit. Yeah. I plugged in a keyboard, and let's plug the HDMI cable in. Okay, moment of truth. Let's press the power button on the PSU, and we have some nice LEDs right here. I'm going to short the power switch pins, and it turns on. It's complaining about RAM. Let's try reseating them. It's not a good way. Let me get something else, like a box. Yeah, I found this. Yeah, this is much better. I'm reseating the RAM. Okay, let's try again. Power supply is on. It's still complaining about RAM. Let me try a different cat. And let's also clear the CMOS. And use a different kit of RAM. Okay, turning the power supply on. Let's put the battery back in. Yeah, power supply is on. Let's try again. It's not complaining about RAM anymore. The LEDs are cycling. And hopefully we get a post. Yeah, we do. Okay, what does it say? F1 to run setup. Let's plug the keyboard in. Okay. Yeah, we are in BIOS. Let's turn your CPU on. I don't remember where it was in Asus BIOS, but I think I found it. Yeah, 3200 L16. That's correct. Okay. Yeah. Let's save and exit. It's rebooting. Yeah. This happens. Looks like we have a working motherboard. And we are here at the end of the video. Thank you for watching. And definitely check Mainboard Medic's YouTube channel. I'm going to leave a link to his video in the description. If you want to learn about ATX motherboard repairs, his channel is one of the best sources you can find on the internet. Trust me. Thank you for watching. Please like if you liked the video, or dislike if you didn't. Let me know about any suggestions you have, or if you have a question, please ask in the comments. Yeah, see you in the next video. Goodbye.